seconds for temperature to fall down from 40 to 39. Calculate the specific heat capacity of the liquid. Assume Newton's laws of cooling applicable. First case, read this one. So Newton's laws of cooling or Newton's laws of heating, both are same. So what do that law says? Like mass into, there's the basic formula. Temperature, yeah, temperature, I'll call theta, should be equal to K theta minus theta naught. D theta, not dq, only theta it is. So there's a formula, no? So if the temperature falls, if the temperature, so like for Newton's laws of heating, plus sign will be there. For Newton's laws of cooling, negative sign will be there. So first case will be how much it is, looking at this one, 30. So what is this entire quantity? This should be equal to power. So what all that electric heater supplies power. So that what happens, the liquid, like a current will flow, heat will be generated and the liquid will absorb that heat and it will transmit here. So that 30 should be equal to K into 50 minus 20. After this, the electric heater will be switched off. No. So it will start cooling. So it will become from 40 to how much? It will take time, 10 seconds for temperature to fall from 40 to 39 degrees Celsius. Where in surrounding temperature, how much it will be? The same thing. So surrounding temperature, 20 degrees Celsius. So in this case, it should be equal to how much now? MS 42 initial, so minus initial final is how much? 39.9 minus initial 40 time, this should be equal to K into 40 minus 20. Average, no? 39.9 plus 40 divided by 2 will take it to be 40 only. So dividing equation 1 and 2, we'll get the thermal capacity, specific heat capacity, means M into S is asking. This is Newton's laws of, this is heating, this is cooling. Specific heat capacity, no, is asking S. So the answer will be, you do calculation later on, 8,000 joule per kg per degree Celsius. Objectives, very, very important. Now what is that K? K depends on what? Again, K. Shall I say K proportional to cube of temperature?